Hello my dear students, today we are going to learn about subatomic particles. Generally we were in the imagination of atom cannot be divided. Okay, so atom can be divided into subatomic particles. We can say this statement based on the new experimental facts. So according to the new experimental facts, atom can be divided into subatomic particles. There are many subatomic particles. In those subatomic particles, stable subatomic particles are electron, proton and neutron. These are stable subatomic particles. In these three, first we are going to focus on the discovery of electron. We need to focus first on equipment which we are using. That is nothing but a discharge tube. It is a glass tube where both ends are sealed with metal plates, and it is having one connecting wire. Both plates are having connecting wires, and that discharge tube, that glass tube, is having one pump, which is this one here. This pump, this is a vacuum pump. We can reduce the pressure which is inside, present in the inside. So now this is a simple explanation about that discharge tube. Here what we are going to do is, first we are going to apply high voltage. Here you see this, I said two metal plates are sealed inside of this glass tube. So one metal plate is connected to the negative terminal of the electric current, and positive terminal, another one is connected to the positive terminal of the electric current. So whenever you give and you pass high voltage of electricity, if you pass high voltage of electricity and low pressure with the help of that vacuum pump, you have to reduce the pressure. So 0.01 mm of Hg pressure we are maintaining inside, very low pressure. Okay, so now whenever you create like this type of high voltage of current condition and low pressure, some rays are traveling from the negative charged plate to positive charged plate. Here negative charged plate is functioning as like a cathode, and positive charged plate is functioning as like a anode. So some rays are traveling from cathode to anode. So here these rays are not visible to our naked eyes. So that's what here we need to observe their behavior. So to observe their behavior, we are using a fluorescent screen, or phosphorescent screen also you can use. But here we are using fluorescent screen. So whenever this rays touches that screen, they can travel even in the metal plate and they can touch the fluorescent screen. Whenever they touch that fluorescent screen, automatically they glow. That screen, whenever it hits that screen, it glows. So that spot glows. So like that we can observe their behavior. So finally we realized some rays are traveling from cathode to anode. Those rays we can call it as like a cathode rays. Okay, these cathode rays, why these are traveling from cathode to anode? Because those cathode rays are having negative charged particles. That's why they are moving towards anode side. So therefore these cathode rays are having negative charged particles. This total experiment was conducted by J.J. Thomson. Okay, these cathode rays were discovered by J.J. Thomson. Later, these cathode rays containing negative charged particles, those particles were named as electron, that name was proposed by Stoney. Here you see this, Stoney. And this experiment are nothing but a cathode rays discovered by J.J. Thomson. Okay, this tube was introduced by Crookes, William Crookes. You can see here, William Crookes. You can see here, William Crookes. Okay, so this is about discovery of electron, and next we need to discuss about the properties of cathode rays. The rays which are coming from cathode to anode, those rays we can call it as like a cathode rays. Simply I want to tell you, characters are nothing but properties. First property you have to notice here, cathode rays always move from where to where? Cathode to anode. Okay, that is first character. Now coming to the second, we have discussed already. What is that? These rays are invisible to our naked eye. Have you got it? So invisible to our naked eye. So that means you can't see with our eyes, but their behavior can be observed with the help of fluorescent screen or phosphorescent screen. Have you got it or not? Now next you need to think about, here you see these rays without electric field and magnetic field, they travel in a straight line. They travel in a straight line. Without electric and magnetic field, they travel in a straight line. I think you may get one doubt. Whenever you use magnetic and electric field, what will happen, sir? when you apply electric and magnetic field, they deflect towards favorable direction side. That means, for example, if you apply magnetic field, these cathode rays deflect towards south pole side. Whenever you apply electric field, they deflect towards positive pole side. So that's why if you apply electric and magnetic field, automatically that cathode rays deflect. And next, last characteristic or property of the cathode rays, very very important. Cathode rays are not depending or nothing but independent on the material, nature of the cathode material. So I told you cathode plate, anode plate, two plates, metal plates we have taken. These cathode rays are not depending on the plates, metal plates, whatever you take that metal plate, you take. So it is not depending on the material which we are taking in the metal plate. Okay, and it is also not depending upon the gas which is present inside of the discharge tube. So focus on these 2 points. Okay, so it is independent on the material of the cathode, nature of the material of the cathode, and nature of the gas which we are taking into the discharge tube. So it is not depending on all these points. Okay, and that's why we can say in all materials or nothing but all elements, the constituent particle is electron. You need to have clarity, because these rays are not depending on the material. Any material you take, they are coming. That means if you take any material or any element, that this electron is definitely present inside of that metals or elements. So it is a constituent particle, we can decide. These all are the characteristics of the electron, and we will discuss